Okay, and we only have one more section to cover. And the test is next week already. I posted the practice test. Yeah, but we're not ready for that yet anyway.
So this next test is just on the graphing.
Yeah, it's all graphing. Well, some of the problems are you're given a graph and then you have to write the equation. Also. Okay, which numbers do we need to go over?
Infinity.
What?
Infinity.
Oh no.
No questions in this class? I find that hard to
You
believe.
know what this is infinity? I don't understand what that means.
What infinity?
You just
No questions. Okay, I can walk around now and check everybody's homework then. John? Okay, no questions then? That's good then. You can wait till I walk away. Okay, tonight's homework is basically now shift the graph left and right. So we already know how to like stretch and shrink horizontally, stretch and shrink vertically, and shift it up and down, right? But what about left and right? I don't know, like I said yesterday, I don't know how come they don't just put it all together. But we know how to do that, right? Like for example, if you know what the graph of this looks like, how do you graph this? You shift it 1 to the left, and then what if you had this? You would shift it 3 to the
Right.
right. So the same thing. You're not going to see anything different. So why don't we do an example? Why? So tonight's homework, you're going to have like all 4 things that you have to do to the graph. So how about 2 sine 3 x minus, no, let's do 4.
Okay.
Pi over 8 plus 1. Okay, so let's go back to the base graph. The base graph is going to be y equals sine x. Okay, so basically, so this is what you should do. 1, 2, 3, 4. Right, we should be all experts at this already. And where does sine start? Does sine start here? A, B, or C?
It'd be
B, and then it goes like this. Like that. That's one period, and then copy and paste is needed. Now, tomorrow's quiz, you're going to have to graph 2 periods, right? So, I have to copy and paste. Okay, so, what does this do to the graph? Like, you put a 2 there.
it increases the
It
y.
multiplies the y values by
2.
2. So this becomes 2 and negative 2. And then this 4 right there. What does that do?
It's
That, what does that do?
It
It actually shrinks, but what did I tell you guys? Don't think stretch and shrink, just think it multiplies the x values by 1/4. So if I multiply this by 1/4, what does that become? 2 pi over 4, which is pi over, come on. 2 goes into 4 2 times. Pi over 2. Come on, we gotta be able to do arithmetic. And then, of course, if that's pi over 2, then that's half of it, which is pi over 4. And then if you take another half, that's pi over, what's half of pi over 4?
Over 8.
Thank you. And then, like if you have 1/4 of a pi, I cut that in half, you get 1/8 of a pi, right? And then that means each hash mark is pi over 8. So 1 pi over 8, 2 pi over 8, 3 pi over 8, and so forth, as you have to label. Okay, so you should always do the horizontal shrinking and stretching and vertical stretching and shrinking first. You always do that. Then after you do the shifting or the translating, right? So what does this do to the graph? We had this on last night's homework. You shift it up 1, but we mustn't put it all together. And then what does that do then? That's gonna shift it pi over 8 to the
Left.
right. Right. We just did it over here. It's the same thing. So what all you have to do is take this graph, shift it pi over 8 to the right, and 1 up. So now we're gonna get the real graphs, and we'll do it in blue then. So if I shifted pi over 8 to the right, what does that mean?
The start point goes.
Okay, so this point here is gonna go pi over 8 to the right, so it's gonna be here now. But then we're gonna again, I turn around and here's Chun.
Not even.
Yes. You telling me I'm lying? I'm a liar?
No, I'm
Okay,
just
that's what I
saying.
thought. You go pi over 8 to the right and 1 up. So you just take all the key points and go pi over 8 to the right and 1 up. So here, I guess we're gonna need one more there then. So here's this point here. Go pi over 8 to the right and 1 up. So this point here, pi over 8 to the right, 1 up. What about this point? Pi over 8 to the right, 1 up. And then finally this point. I guess we need one more then. No, that's too soon. I get it there. So pi over 8 to the right and 1 up. So here we go. Whoa. And then copy and paste as needed.
Okay.
So, I mean, come on. If you can shift up and down, you can shift left and right, yeah? Now, you know what your book calls this? When you shift a sine or cosine graph, or I guess the tangent and cotangent ones too, left and right, they call that a phase shift.
Phase?
Phase shift.
Phase.
What do you think I was saying? Phase shift?
No.
They call it a phase shift. So so you're gonna find in your book, they call this the phase shift is pi over 8, which means you shifted it pi over 8 to the right. If the phase shift is negative, that means you're shifting it to the left. Yeah, but see, I don't like to just group the trig functions together because this applies to any function. I don't know why they just don't say the graph is shifted pi over 8 to the right and 1 up. But that's perfectly fine. But they want to use the term phase shift. Well, when I was going through high school, that's what they did, but come on. We don't need to do that now. Okay, so the hardest examples on tonight's homework are going to be where you have to do all four. So just remember, do the stretching and shrinking first, and then do the translating second. Always do the stretching and shrinking first. And then shift it right, left, up, and down later. Okay, let's do another one. Oh, we're going to finish early today. Now the book, though, here, in fact, why don't we just pick one right out of the book. Tonight's homework, I believe, was 3 to 25 odd. Okay, why don't we do an even one? Let's do something challenging. How about number 14? This is not really challenging, but let's do it anyway. -3 cosine -2x plus pi over 2. Okay, first thing. See, we need to make it look like this. Does that look like this? No, see, something's wrong over here. See how the x is all by itself there in parentheses? So you know whether to shift it left or right? So what we need to do is we need to put it in that form. So how can I make the x all by itself like that?
Right, but negatives.
You factor.
Factor it out.
You can't, yeah, you factor out a -2 right there. Okay? Now, if I factor out a -2, what's gonna be left?
X plus
X minus pi over 4. What? It's called factoring, people. Okay, now, you know how you can check to make sure you're correct? If I take that -2 and distribute it, do I get this thing right there? Remember, factoring is just the reverse of the distributive property. That's all it is. Okay, so what is our base graph? Our base graph is this, right? Of course, cosine x. But then remember, we were doing the stretching and shrinking first. So you got this then. Y equal -3 cosine -2x, right? That's kind of like the base graph there. Now, do you guys remember how to handle this? What is, okay, here, let's review. What is cosine of negative theta? It's on your identity sheet.
It's cosine.
It's cosine theta. And then let's review. What is sine of negative theta?
It's sine.
Negative sine theta. What is tangent of negative theta?
Tangent.
Negative tangent theta. Have we forgotten? And what kind of identities did we call that again? These are called the odd even identities, or the even odd identities. Because here, let's go back to algebra 2a. If you have a function where if you plug in negative x for x and you get the same thing that you started with, we call that an even function. Did you guys learn these words before, even and odd?
Even on the
Okay? And then if you plug in negative for x into any function and you get the opposite of what you started with, we call this an odd function. And what did we learn? Even functions are symmetric about the y-axis. Odd functions are symmetric about the origin. Okay, who said x-axis? Look, if a graph is symmetric of, here's the x-axis. If a graph is symmetric about the x-axis like that, it's not a function. It's not a function, because a function has to pass the vertical line test.
No.
It doesn't. What? Now you're blaming other people.
Doesn't ask you.
Whatever, the main thing is you learn. So what is this telling you? If cosine of negative theta is equal to cosine theta, that means cosine is an even or odd?
Even.
It's an even function. If sine of negative theta is negative sine theta, that means sine is an odd function, right? And tangent, you can see, is also an odd function. But that makes sense because, Mr. Park, look at the graph of cosine. Here's the graph of cosine. I'm just going to draw a quick sketch. This is what cosine looks like, right? And it keeps on going. Isn't the graph symmetric about the y-axis?
Yes.
Right? That's why it's even. That's a property of even functions. It's symmetric about the y-axis. What about sine? Here's the graph of sine. Ooh, ooh. It's symmetric about the origin. You guys know what's symmetric about the origin? Everybody here took geometry, right?
Yeah,
You have 180-degree rotational symmetry. So basically, any point you have there, you have the same point on the opposite side of the origin, like that. It's 180-degree rotational symmetry. What about tangent?
same thing.
Okay, remember tangent? You got the two asymptotes like this, and they whoop, right? And then of course you got more like this, right? But
One
is that graph symmetric about the y-axis or the origin?
origin.
The origin, because look, any point you have over here, you have the same point on the opposite side of the origin. So that's why sine and tangent are odd functions. See how it all fits together? Anyway, going back to this problem now. So, what is cosine of negative theta equal to? Just cosine theta. So, what you have to do is you have to start by drawing this graph. And then you shift it pi over 4 to the
Right.
right or left.
Right.
Right. Okay, so here, I'm gonna keep it on this side of the board since we're filming. So I need to erase. Go. So before you even start, if it looks like this, whatever number's over here, you have to factor it out. Okay? Okay, so we start with the cosine graph. 1 and negative 1, correct? Cosine looks like this. Okay, what does that 3 do? It multiplies the y coordinates by 3. So, what does this 2 do here? It multiplies the x coordinates by
Half.
1/2. So if I multiply that by 1/2, the 2's cancel out,
Pi.
and you get pi.
What's the
Which of course means this is pi over 2, right? Half, and then you half it again, pi over 4. So each hash mark is pi over 4.
3 pounds.
Pi over 4, 2 pi over 4, 3 pi over 4. But this negative sign reflects it over the x-axis, so it's going to look like this. It's got a bug. There. Okay, now, so we got that. Remember, do the stretching and shrinking first. Now, if there's any shifting up or down, now you look at it. This will shift the graph pi over 4 to the right. So every point goes pi over 4 to the right. So this point goes over here. And see how like each hash mark is pi over 4, so that's good? This point goes over here, this point goes over there, and this point goes, wait, this point goes over here. And we're gonna need one more hash mark. So what would that be, that hash mark? 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4,
5 pi over
5 pi over 4. So this point down here goes over here now, and then you just connect the dots. And and then copy and paste as needed.
Okay.
Easy. So I could have taught you all of this on the first day. Just take the base graph, but the book wants to break it up. That's it, we're not gonna follow the book anymore. You follow me. Okay, so any questions on this? So you're gonna do this on all the graphs, the tangent, the cosecant. So the key is you gotta get that base graph, do the stretching and shrinking first, and then you shift left, right, up and down last.
How many graphs do you have on the quiz?
Okay, let's discuss tomorrow's quiz. Tomorrow's quiz, you're gonna have 6 graphs, one of each. What? Gonna have one of each? Okay, here is your practice quiz. I didn't put it, because, I mean, I can just make up anything I want. Okay, I'll just make the practice quiz right here. You're gonna have 6 problems, 6 graphs, and you have to graph 2 periods of each one. Now, if you remember anything, there's not gonna be any shifting left, right, up and down. All you're doing is just shrinking and stretching horizontally and vertically. So tomorrow's one is a piece of cake, unless it's not. Okay, y equal, I don't know.
3 cosine.
Wait, let me check the quiz so I don't give you the exact same problem. We don't want the exact same problem, do we?
Yes, we do.
Okay, I got it. So here's your practice quiz. 3 cosine 2x, y equal, I don't know, negative 2 sine pi x over 4. Y equal 2 tangent, give me something here, 3x, I guess we should put it in parentheses. Now we need a cotangent graph. How about negative
1.
negative 1 cotangent pi x over, give me a number.
4.
6.
4, okay. It doesn't matter. Okay, now I'm trying to think. 2 secant, no, let's do negative 2 secant pi x over 6, and then y equals 3 cosecant, give me a number.
4.
No,
6
just
pi.
a regular number.
5.
How about 3x? No, we already got 2x, 3x.
5.
Let's go with 4x then. You gotta mix up the numbers. There's your practice quiz right there. You're gonna have one of each. Okay, let's do this, yes.
Hang some water.
Yeah.
There's like assign problems and do them on.
No, I wanna do it so that we get it on the video.
Oh, okay.
Did you, on the camera doesn't look like it's, did you touch the camera, John?
No.
Okay, well, it's just, no, let me check that.
You're recording it on.
We could just be videoing the poster on the left then. No, it's still good. Now so the key to tomorrow's quiz is you gotta know the base graphs. Okay, for number 1, what's the base graph?
Cosine.
Cosine x, so this is what you gotta do. 1, 2, 3, 4, right? This is the base graph right there. I don't like that one, it should be a little bit lower. Come on, if that's 1, we gotta make it the same amount. Now, where does cosine start? Cosine starts up here, over there. A, B, or C?
I'm sorry.
There we go. That's the problem then, huh? Where does cosine start? A, B, or C?
A.
Everybody starts there? Yeah, because think about it. Cosine of 0 is 1. Right, so it's gotta be 1. And then it goes like this. How come I'm drawing dotted line?
Because it's the original. It's the parent graph.
Well, actually, we could have done solid line.
Oh, we could just change the.
Okay, that's 1 period, right? Okay, now, what does this do to the graph? It multiplies the y coordinates by
1/2.
what?
3.
3.
5.
So, Tuga. What does that do to the graph? It
1/2.
multiplies the x coordinates by 1/2. So if I multiply that by 1/2, the 2's cancel out and you get pi. So that means this is pi over 2, this is pi over 4. Each hash mark is pi over 4, so that's 3 pi over 4, correct?
Yes.
Finished! So how many points do I get? Now each one will be 3 points. How many points do you get for that?
3.
No, you get 2 out. I just told you, you gotta graph 2 periods. Have we forgotten? Yeah. Okay. So you gotta read the directions, so you gotta graph 2 periods. So 1, 2, 3, 4. So that's 2 pi. And so copy and paste. Or you can do it on this side. I don't care. You can do it on that side, or you can do it on that side. Whatever, as long as you get 2. Ignacio, question?
No.
Ta question, il est beaucoup pas fait. Mais nous manquons toujours la fin. Non, ne regarde la télévision. Pourquoi? La tout pas la danser là. S'il te plaît, maman, quand 5 minutes.
What language are you speaking?
I thought I was speaking French.
Yeah, you
1, 2, 3, 4. I'm trying to concentrate here. Alright, the next one is a sine graph. Sine graph, where does sine start? A, B, or C?
B. 8.
Oh yeah, it's B, it's B.
B.
It's because sine of 0 is 0. And then does it go up or does it go down? It goes up like this. How come I did that dotted line? Because there's a negative there. Now, if you want to just go, oh, a negative sine graph, then you're going to go down then, right? You want to do that first then? Okay, let's do it first. That negative sign means reflected over the x-axis. Let's do that first then. Reflected over the x-axis. Okay, now what does this do to the graph? That will multiply the y-coordinates by 2. What does that do? That will multiply the x-coordinates by 4 over pi. So times by 4 over pi, the pi's cancel out, and you get 8. And then, that's half of it, then you half it again. Ooh, each hash mark is 2 then. Ta-da! There you go. How many points do I get for that?
2.
2, and then we need 2 periods. So we need 16, and then just continue, copy and paste, baby. Woo! Now I got 3 out of 3. So easy.
Doing slippers.
So again, what? The key is you gotta know the base graph because everything is done to the base graph. Just like algebra 2b, remember all the base graphs you had to know for that? I forgot everything. Like this, y equal x squared. I think what was on the final exam? Y equal x cubed. Y equal 1 over x. Y equal 1 over x squared. Y equal e to the x. Y equal natural log x. Right? All your base graphs. Is that bringing back memories?
Terrible.
Well, in Trig, we only have 6 base graphs. Okay, number 3. It's a tangent graph, so you start by drawing the base graph. Now, I don't know how you guys do, like what I told you, I like to remember from negative pi over 2 to pi over 2. That's what I like to remember. Because these are 2 asymptotes. And then, does tangent go up or does it come down? It goes up like this. Anyway, you know how you know? Oh, maybe we should put the 1 and negative 1 in. That's because tangent of pi over 4 is 1. Right? Everybody remembers that. So to get from here to here, you gotta go up, right?
Correct.
Because tangent of 0 is 0, tangent pi over 4 is 1, so it goes up like that. Okay, what does this do to the graph? It multiplies the y-coordinates by 2. So this becomes 2 and negative 2. And then what does that do to the graph? That will multiply the x values by 1/3. So if I multiply this by 1/3, that becomes pi over 6. And that becomes also pi over 6. There you go. That's 1 period right there. And all you gotta do is copy and paste. Okay, now if I were to copy and paste, what's this then? Look, once you do that, each hash mark is pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2, right? And then tangent goes up. There you go. Simple. Simple. Okay, number 4. This is a cotangent graph. So you need to remember one period. Now the one I like to do is right here, pi. And so here are the two asymptotes, and then does cotangent go up or does it come down? Okay, so. Oh, darn it, I should have drawn it in a dotted line. You know why? Because look, the negative sign. It means we gotta reflect it over the x-axis. What a dumbo I am.
On the spot.
Huh? I'm too hard on myself. Yeah, okay. So, if I reflect it over the x-axis, the thing would look like, what am I making there? Whatever. It was like this. It kind of looks like a tangent graph. Yeah, a cotangent graph is the same as a tangent graph, except it's flipped over and shifted. That's all it is. All right. Now what? What does that do to, well, where this one doesn't do anything. What does that do to the graph? That multiplies the x coordinates by 4 over pi. So if I multiply this by 4 over pi, now pi's cancel out and you just get 4. Which of course means that's 2. And then just copy and paste. You want to do it on the left just for variety?
Sure.
No, we don't like variety, just do the same thing. So 2, 4, 6, 8. And then ooh. So after I'm done, you know what you guys should do? You should take a picture of
But
the work.
it's on film.
Yeah, but why not just take a picture and you have it like right there? Otherwise the film, you gotta wait till it's done, you know what I mean? Whatever, Danny. Okay, 5. We have a secant graph. Okay, now, what is a secant graph again? It's the reciprocal of cosine. So, to graph secant, what you do is you start with the cosine graph. 1, -1. Cosine looks like this. And when you guys did your homework, did you guys get good at humping?
Yeah.
The humping technique. Well, you weren't here. You didn't watch the video. There is no video. You know why? Because you didn't email me to tell me to video.
Guys,
Strike one.
the book.
So whenever read the book. So what did the book say? I'm curious because I don't read the book.
I'm gonna just read the book.
But you're gone.
Future tense.
Okay, so whenever the graph touches the x-axis, in other words, whenever the y-coordinate is 0, there will be a vertical asymptote. Because the reciprocal of 0 is undefined. And then, if the graph is humping down, you hump up. And if it's humping up, you hump down. Right? So that's what the graph of one period of secant looks like. Now, there's a negative here. It means I gotta reflect it over the x-axis. So if I reflect it over the x-axis, instead of what? It's gonna be this then. It's gonna be this. And instead of going like that, it's gonna be like this. And then instead of that, it's gonna be like that. Correct? Yeah. Just reflect it over the x-axis. And then this part is simple. What does that do to the graph? That multiplies the y-coordinates by 2, so that's easy. And what does this do? That will multiply the x values by 6 over pi. So if I times this by 6 over pi, the pi's cancel out. It's the park. I like it when the pi is over there. Did you guys notice that? Then you just get regular numbers, yeah? Yeah, but 2 pi is a regular number. You get 12, which means half of it is 6 and half of that is 3, which means each hash mark is 3, so that's 9. And then all you gotta do now is copy and paste. Shall we just go to the right, Okay, so that's pretty ugly. And then we just continue the asymptotes. And continue the humping. Hump down, hump up, hump down. Oh, that stops right there. Yeah. How you like that humping? Whatever. And then finally, number 6, see if you can squeeze it in right there. This is a cosecant graph. Cosecant is the reciprocal of sine. So, okay, so you know you can graph 2 periods, so let's make it longer right here. 1, 2, 3, this not enough, so yeah. 1, -1. So sine looks like this, right? That's the sine graph. And now to graph the reciprocal, whenever the graph touches the x-axis, right there, you're gonna have vertical asymptote. Again, because the reciprocal of 0 is only 5. And then since it's humping down, you hump up. And since it's humping up, you hump down. Like that. And then we don't have to reflect it over the x-axis, so that's good. So what does this do to the graph? That will multiply the y-coordinates by 3. So you guys got it. And then what does that do? That will multiply the x-coordinates by 1/4. So if you multiply this by 1/4, the 2 goes into 4 and you get pi over 2. So this is pi over 2, half of that is pi over 4, and half of that is pi over 8, so each hash mark is pi over 8. 1 pi over 8, 2 pi over 8, 3 pi over 8. And then you copy and paste. So, so, Hakuna Matata. Right there. See, this is not hard. You just gotta know the base graphs. Do we have all the base graphs down? Ignacio?
How many points do we have to label?
If you just did what I did, you're good.
Okay.
What do you mean label?
Like pi over 2, 3 pi over 8.
Oh, you mean like the hash marks?
Yeah.
No, see look, if this is pi over 2, then you double it, it will be pi over here, right? I mean, that's good. In fact, if you just put pi right there, that's good enough. Right? Because if you have pi and you got 8 hash marks, that must mean each one is pi over 8, right? You know what I mean? No, the reason I'm doing that is because on the test later on, I'm going to ask you, list all the asymptotes of this function. And then if you have it right there, you can see it easily, yeah?
That's sad.
Did everybody get a picture? Take a picture of this. But isn't this like exactly the same thing as you did on the homework?
Yes.
Yeah. And then if you're the teacher, are you gonna give one of each one? Oh. Okay, so when is do I see you tomorrow? So tomorrow's the quiz. We go take the quiz, go over the homework, no more lecture because we learned everything already, and then the homework is the practice test. Don't worry about that now though. Worry about that tomorrow. And then we got a whole bunch of like